if you see that AMGM is getting applied, you will be in and out of the question within a minute. So this makes it very helpful in securing more marks in least possible time. So let's start. AMGM inequality. The property itself says that arithmetic mean of n number of data points is going to be greater than equal to the geometric mean. Now, if you remember, arithmetic mean is sum. So A1 plus A2 plus A3 till an divided by n. This is what arithmetic mean is. Summation divided by number of items that you added will be greater than product of the items raised to the power 1 by n. This is what AMGM is. This is the only statement that you need to know about AMGM. However, its application is very agile. Now, before we move ahead, there are certain constraints, there are certain situations in which AMGM can be applied. Only when these constraints are met, then AMGM can be applied, and the constraint is very simple. All the numbers need to be positive. So A1, A2, A3, all the numbers that you are taking, as part of your arithmetic mean and geometric mean, they have to be greater than 0. The second constraint is, and this is not really a constraint, this talks about when do we get equality. Now, in general, what will happen in your CAT exam, you will get predominantly two type of questions from AMGM. One would be find the value of xxx, or the second would be find the number of solutions of xxx. In the first situation where you have to find the exact value, most probably the equality is what you will justify by using AMGM. That boss, you have given me that GM is greater than equal to AM, but I know AM is greater than equal to GM, which means AM will have to be equal to GM. So when is it that you get equality in AMGM? When all of the quantities that you have taken are individually equal to each other. When this happens, you will have the arithmetic mean to be equal to the geometric mean. Now, constraint that we put that all of these items have to be greater than 0. Uh, the reason for that was that geometric mean might not be defined if certain values are negative, because you have a 1 by n situation here, in which case if this becomes negative and 1 by n is something where n is even, then you will end up with an imaginary number there. So that is the reason why we do not define AMGM for negative numbers. However, there is a workaround for that. So the modified constraint is all should be positive, or all should be negative. You should not have a mixture. You should not have that A1, A2, A3 are positive and the rest are negative, or vice versa. So the reason for the second one, the first one is clear. We use that liberally. The reason for second one is, let's say I am saying that x plus y is greater than equal to 2 root xy. Now, if x and y are negative, x plus y will be negative. However, root xy would be defined, because x into y would be a positive number. So root of xy will be defined. So 2 root xy would be a positive number. So we cannot have a negative number greater than equal to a positive number. However, however, if I multiply this x and y with -1, if I say I have minus x and minus y, and I call this as capital X and capital Y, can I now apply AMGM on capital X and capital Y? In which case I will get capital X plus capital Y is greater than equal to 2 root capital XY. This is possible because X and Y are positive numbers. And now to the fun part. What if I multiply this inequality with -1? on both sides. So minus x plus y. Now, because I'm multiplying with a negative number, I will have to switch the inequality sign. So this will become less than equal to minus 2 root xy. And this will become x plus y is less than equal to minus 2 root xy. So from a negative perspective, if both the numbers are negative, if I take this 2 here, I will get the arithmetic mean will be less than equal to the geometric mean with a minus sign. This gives me a useful bound on the negative side when x and y are negative numbers. Some of the doubts that I can see that you guys are having is, what if there were odd number of terms? So let's take odd number of terms. Let's say I have x, y and z. All three of these are negative. So I will take minus x, minus y and minus z. All right. So this is capital X, this is capital Y, this is capital Z. All three of these are positive, which means capital X plus capital Y plus capital Z by 3 is greater than equal to cube root of x, y, z. Now, if I multiply this with minus 1 on both sides, I will get minus capital X minus capital Y minus capital Z is less than equal to minus 3 cube root of capital X, Y, Z. And now this I can replace with x plus y plus z is less than equal to minus 3 cube root of, this will become minus x minus y minus z. So minus sign is coming 3 times. So this will become minus xyz. And this minus of cube root I can take outside and I can make this positive. So this is negative. This also you should be able to observe that this is also a negative number. Cube root of xyz, because xyz, all three of these are negative, so their product is going to be negative, which means the cube root is also going to be negative. So a negative number is always less than equal to this particular negative number. So what this actually tells me is, let's say x, y, z are certain variables which are either always positive or always negative. I will find the magnitude of 3 times cube root of xyz, just the magnitude. I will mark this here and I will mark the negative one of that with the same magnitude here. Your value will either lie on this side or on this side. If xyz are hard positive number, then there is no need of discussing this. However, if xyz can simultaneously be negative, then you will have a situation like this. You can either take this positive values or take this negative values. So your range of x plus y plus z would become something like minus infinity to minus some value, and let's call this as this value as p, minus p union p to infinity, and you will put a square bracket here. If one is positive and second is negative, then you cannot use AMGM inequality. Then you cannot conclusively write any particular solution. So is the approach clear? 99.9% you will only be using the positive variant. In fact, the existence of positive variant is how you will determine that you have a AMGM sort of situation going on. However, if you do come across on the rare chance that the numbers that are given to you are negative, you can deal with them like this by making their positive counterparts and then apply the AMGM and then multiply with minus one sign to get back to your original numbers. So, if I go through some of the doubts that you have said, will it be affected by odd or even number of terms? No, Tushar. So, as you can see, the magnitude is what we are focused on. This magnitude is what you will be greater than on the positive side and less than on the negative side. What if number of terms are odd? Again, that is clear. Odd even does not matter. For positive, nothing matters. Just the existence of positive values matters. For negative, again, odd even does not make any difference to us. If one is positive, second is negative, that will not work because then you can have an under root of negative situation. Similar nature is mandatory. Yes, either all numbers positive or all numbers negative. In this situation, you don't really have to memorize this argument. You only need to know that AM is greater than equal to GM when all numbers are positive. If the numbers are not positive, you can always convert them to positive numbers, right? In the way that I did. I took the negative counterparts as the variable, then applied AMGM, and then multiplied with -1 sign, flipped the inequality sign, and got the result in my initially given variables. So your approach, if you have negative variables given, all of them negative, would be you write minus x as capital X, so on for all, apply AMGM, then you multiply with -1, flip the sign from this to this, and then you will land up with small x, small y, small z only. General rule of thumb is that all of them have to be positive. So the property is clear, the constraint is clear, all of these need to be positive, with the subtext that all of those need to be of the same sign. If all of those are negative, I can convert all of them to positive, apply AMGM, and then multiply with a -1 sign. However, I will be using this. The other part of the constraint is that when is this equality respected? The equality will be respected when each individual number that I am using to write AMGM are equal to each other. And this value, when AM is equal to GM, whatever this value is, this will be the minimum of the AM because AM is greater than equal to GM, and this will be the maximum of GM because GM is less than equal to AM. So this is the central value at which both of these can converge given that all of the data points are equal to each other. All right. So moving on, certain common AMGM functions, certain things that as soon as you see, you should think of AMGM, or some internal alarm should go off in your mind that AMGM is something that can be used here. A proper algorithm for application we will shortly discuss, but let us first, reconsider some of the common AMGM functions. X plus 1 by X. This is one of those functions that repeats across topic areas. We previously saw it, I think, in the last class itself. So the reason why this is a fun AMGM function is, see, if x is positive, then 1 by x is positive. If x is negative, then 1 by x is negative. So the constraint that I would have for applying AMGM, that is not really an issue for me here. Both of these values, x and 1 by x, are of the same sign. Secondly, the product of these two numbers, x into 1 by x, is a fixed number. Now, one thing which we will shortly again come to is, when I do want to apply AMGM, I would, in an ideal world, want either side to be a fixed constant number so that I can immediately make a statement like this, that x plus 1 by x is greater than equal to 2. This is a very powerful statement because on one side I have a constant number. Now, another situation where you can have AMGM sort of thing going on is when you have linear functions given to you. For example, they say 2x plus 3y plus z is equal to 10, x, y, z are greater than 0. So the two things that I wanted to observe, x, y, z are greater than 0, and there is a combination of their sum which is a fixed number. So what that allows me is to reorganize everything that I have on the constant side. This statement is a statement of constancy, and this is something I can reorganize based on what they ask. For example, let us take it here. So this is what we have: 3x plus 2x plus 3y plus z is equal to 10. This is what I have been given. All right, x, y, z are greater than 0. Now let's say they ask me what is the minimum value of or maximum value of x square y cube z. Does this look like you to be a geometric mean? Forget if you can actually make it happen or not, but all the numbers are getting multiplied to each other. So if I did ask you, if I twist your hand and say, would you tag this to an arithmetic mean or geometric mean, what will you say? You will say this is more similar to a geometric mean because these numbers are getting multiplied. right? So what is it that it's the GM of is what we have to determine. Now, if you remember, A plus B plus C plus D plus E plus F, if this is the arithmetic mean, then I get A, B, C, D, E, F raised to certain power on my geometric end. Now, of these six terms, I want two to be of x so that I get my x square, right? So I will tag this to x and x. I need three terms of y so that I get y cube. So I will take C, D, E as y, y, y. And I need one term of z. So I will tag f as z. Now I want two x's, three y's, and one z here. Let us make that on the arithmetic mean side. Luckily, in the way that they have asked me the question, I already do have two x's, so I will write that as x plus x. I have already three y, so I'll write it as y plus y, and I have one z given. So this expression is the arithmetic mean. It is going to be greater than equal to the geometric mean, which is x square y cube z raised to the power 1 by 6. So this thing is constant. So 10 by 6 is greater than equal to this value, or the maximum value of x square y cube z will be 10 by 6 to the power 6. If I ask you at what relationship between x, y, and z uh, do you get this result? So equal, yes, the equality in AMGM happens when each individual term that I take for writing AMGM is equal. So some people at this point make this mistake that I started with this 2x plus 3y plus z is equal to 0. So the equality for my AMGM will occur at 2x is equal to 3y is equal to z. That is wrong. Did you use 2x to write your arithmetic mean, or did you use x? You used x, right? You wrote it as x plus x. So these six terms that are written here, these six terms have to be individually equal to each other. So you will write x is equal to x is equal to y is equal to y, z. So x is equal to y is equal to z is when this particular equality will be respected. Clear so far? The method, in if in case, if at all they ask you for a linear inequality like this. Now let's say that the numbers were not so supportive. Let's start with this example only. 2x plus 3y plus z is equal to 10. This constraint remains, x y z is greater than 0. Let's say they ask me x y square z cube. What is the maximum value of this? So I will again go by this approach. In my mind, I have six terms here. I have a, b, c, d, e, f. Now I want one term of x. So that I will tag with A. I want two terms of y because I have y square here. So B and C I will tag to y, and D, E, F I will tag to z. Alright. So now let us convert A, B, C, D, E, F. I want only one term of x. So in this addition, the term of x will be consumed entirely by A. So A will be equal to 2x. Now B and C have to together account for 3y. So I will write it as 3y by 2 plus 3y by 2. This is B, this is C. Z has to be accounted for by D, E, F, three values. So I will write Z as Z by 3 plus Z by 3 plus Z by 3. This is D, this is E, this is F. So when I write the arithmetic mean, I will write it as 2x plus 3y by 2 plus 3y by 2 plus z by 3 plus z by 3 plus z by 3 whole divided by 6 is greater than equal to, now I will write the product of these numbers, 2 into 3 by 2 into 3 by 2 into 1 by 3 into 1 by 3 into 1 by 3 whole into x y square z cube raised to the power 1 by 6. This entire thing is constant. It will come out to be some number that raised to 1 by 6 you can take outside. This 6 will come here, so this becomes 6 into whatever this value is, that's a constant number. Then you get xy square z cube raised to the power 1 by 6. This is what I wanted to find. And what do you have here? This is still 10, right? I just wrote that 10 in a different way. However, the value is still 10. So now you only have to bring this entire thing here and raise it to the power 6. You will get your maximum value for xy square z cube. And if I ask you, when does this equality happen? Which terms will you equate to each other? The ones that you used to write your arithmetic mean, which were 2x, 3y by 2, and z by 3. So 2x is equal to 3y by 2 is equal to z by 3 is going to be when you have this am is equal to gm. So the third format, which is a common amgm function, is actually an iteration of this x plus 1 by x. If I write x as, a by b, so I will get a upon b plus 1 by a by b, which will be b by a. In this format, it is easy to see that x into 1 by x is going to be 1. In this format, however, sometimes people miss the fact that a by b into b by a is actually going to be a constant number. So this is something you should keep an eye out for. The fourth sort of situation that you can come across is a square plus b square. So a square plus b square by 2 is greater than equal to ab. Now, in the previous 5 lectures that we have had, did you encounter a situation like this? Does the left side look like sum of the squares of the roots, and the right side look like the product of the roots? This is something that can be asked. So this is again one format of that. Area, perimeter, length. So now tell me this. Area is it a product of lengths or a summation of lengths? Area is product of lengths. Perimeter is summation of lengths. So I can always come across a situation where they say that area of this shape is this, what is the lowest perimeter, or they can give me the perimeter as fixed and tell me what is the highest area that you can have given that perimeter is this. All right. Finally, this is quadratic by linear. And this is the most difficult to, observe. Think of it like this. Let's say I get x square, ax square plus bx plus c divided by x. Do you see that this is actually ax plus c by x plus b if I divide by x? And would you say that the product of these two numbers is a constant number, ax into c by x? Which makes it a good candidate for me for applying AMGM because B is a constant number. B is something I would already know. Correct. Let us take another example. Let us say, yeah. So let us say that I have something like x minus 3 whole square, or let's call it, x minus 1 whole square plus 5 times x minus 1 plus 4 divided by x minus 1. Yeah. So I can write this as x minus 1 plus 4 by x minus 1 plus 5. In the first two terms, I can apply AMGM, and the fifth and the third term is a constant number. The trick to spot in quadratic is, numerator and denominator, and you can manipulate that because there is no reason for them to give it to you like this, right? They could have expanded this. They could have given this to you as x square plus 3x plus 4. It then comes down to you to be able to write it like this, in which scenario you would have probably gone for assuming this entire thing to be equal to y and then play on the discriminant. In that situation, amgm would probably not have been too evident. And again, the given caveat which would help you decide should I go for amgm or should I go for discriminant is I would have had to give you that x is greater than 1. and which would have been the giveaway that I want you to deal with the positive numbers, which means that AMGM seems to be a likely candidate right now. All right. So we will discuss these things shortly. All right. So how to identify? The question is not how to apply AMGM, which honestly, if I tell you, you probably would be able to do it. It is how to identify. First thing that you will check for is that the numbers should be positive. Now I don't want you guys to come back at the rate me that boss you just showed that negative maybe you can apply AMGM. I just showed it to you because it's a good way to deal with magnitudes. However, AMGM in CAT or in general also generally gets applied for positive numbers only. People use it for positive numbers only. That is in itself the biggest giveaway that AMGM is going to get applied because the numbers are positive. So this is the first hint that you should pick because it ensures that AMGM is even valid. Because if the numbers are not positive, if the numbers are of opposite sign or negative numbers, then if AMGM is not applicable only, then what else remains for you to identify? Right. Let's say that the numbers are given to you to be positive. The second thing you should check for is, do you have constant sum or constant product, which will help you by giving you a one-sided inequality. You will have arithmetic mean greater than equal to some constant, or some constant is greater than equal to the geometric mean. Even if the sum or product, the ones that you want are not given, but something else is given, it is still a valid option. As I just previously showed to you, for xy square z cube, you honestly wanted x plus 2y plus 3z. However, we were able to manipulate the given equation, the given result, according to what I wanted. So, and that is what I meant when I said AMGM is extremely agile. So, some summation or product should be constant, which will help you by giving you a one-sided inequality. A two-sided inequality, honestly, is not a big deal. All right. Finally, minimum or maximum. There should be some question of minimum or maximum going on. Which is when you can really apply your AMGM, because at the end AMGM is an inequality, and in inequality construes a minimum or maximum. And generally what is usually asked is when is the equality condition going to get respected. However, I have already told you there are two type of questions: find the value or find the number of solutions. So in the number of solution scenario, this thing is hidden well, which brings me to the next topic: concealing the hint. So the exam maker would ideally want to hide these little hints, that you can pick up on and apply AMGM. So they would want to hide that. And the way to do that is, and let us take it step by step. Positive is your hint one, constant sum or product is your hint two, and maxima minima is your hint three. All right. So for positive, one of the easiest way to hide the hint is by using some real world scenario: number of items, lengths, etc., etc. Now, these are going to be positive quantities. It is a given fact. It's a common sense. But they are now, not required to write it exactly with the word positive in the question statement. So this is one of the ways in which they, hide the requirement of positive by just saying that the things that we are talking about are number of items. For example, in the example, 2x plus 3y plus z is equal to 10 that we just took. If I had said that x, y, and z are number of students in classes, then would I really have had to, mention that x, y, and z are positive numbers? Yes, no, no, right? But it is a given fact that they are going to be positive numbers, right? So this is one of the ways they will try and hide the positive hint that we have. So one other way that they can do this is by hiding the positive hint by putting it in a function. Now you know that a to the power x for all values of x is going to be positive if a is a positive number. So if I give you something like 3 to the power x, you should know that this is a valid, situation for AMGM. If I give you log x and I give you x is greater than 1, this is also a sly play on the way of giving information, right? Instead of saying x is greater than 0, which could have hinted you that AMGM is going to get applied, they put it inside a log and they then said x is greater than 1. And most probably you might not think of the positive negative aspect and subsequently not think of AMGM. Some polynomials with constraint. So for example, in the previous examples we took where I had x minus 1 in the denominator, if I give you x is greater than 1, the message for you is that x minus 1 is greater than 0, which makes x minus 1 a good candidate for AMGM. So are you okay with the way of hiding, you know, the individual constraints on the terms, that they have to be positive? They can hide it like this. The second situation that they can try to hide is the constant sum and product situation, that the sums are constant or the products are constant. Again, this can be done by, number of items, total cost, area, hypotenuse. If I take an example, hypotenuse, if I give you as 20, have I given you a square plus b square to be a fixed number? So I gave you a harmless information. Hypotenuse is equal to 20. But the subtext is that boss, a square plus b square is greater than equal to 2 root 20, जो भी आप लिखोगे अपना. And the other side is what? What is AB? AB is your area. So you are now able to relate your lengths of a right angle triangle of base and height with the area. Correct. Total cost, you can make it as a function of number of items and cost per item. They could rely on a single variable, and if they give you that the total cost has not changed, so that becomes a scenario. So in general, to hide this constant sum product situation, they do have to, if they go for a real world scenario, they will have to create a somewhat elaborate situation. It's not going to be as easy as the positive hint that we had. They could also again hide these things in alternate functions. A to the power x and a to the power minus x. Do you know that their product is 1? Yes, they are inverse of each other. It depends on you if you are able to pick up on that. Log a base b and log b base a. Is the product of these two numbers 1? Yes. Will you be able to pick up on that? That depends. If you are able to pick up on that, then AMGM becomes a good option for you. Some product of roots, this again they can play with. They give you a quadratic equation, x square plus 3x plus some variable y. So now it is for you to observe that boss, sum is constant, sum is 3, which means 3 by 2 is greater than equal to root y, which is the product of the roots, right? The final thing, the maxima minima, is generally something they can't really hide, apart from these two situations. Which of the following can slash cannot be one of the solutions? So instead of outrightly asking what is the maximum value of this or what is the minimum value of this, they ask you which of the following cannot be the value of this. And then it depends on you that boss, the answer would be a range which I can find using AMGM. And if I do that, then whichever value is outside my range, it is not going to be part of my answer. Another way, and this is probably the trickiest way to do this, is they give you a function on this side, they give you another function on this side, and we realize that one side I can apply AMGM and the other side is using some other inequality condition, maybe quadratic or something, and we realize that the minimum of this is equal to the maximum of this, which means the value of x is something I can decide. Again, I will have an example for you shortly.